In this video, we look at the work on expectation and variance of discrete random variables for the Unit 2 of the WJEC Further Maths specification. We are expected to be able to use the idea of mean and variance of combinations of independent random variables. We expect it to be familiar with the calculation of the expected value and variance for discrete random variables. We'll also be expected to be able to handle similar ideas for continuous random variables, but the work on continuous random variables will be looked at during the second video in this series. So, the key concepts. For a discrete random variable, the mean is just calculated by working out the sum of all of the values that the random variable can take times by the corresponding probabilities. The variance, which is the same thing as the standard deviation squared, is the sum of all of the squares of the values that the random variable can take times by the corresponding probabilities. And once we've worked out that sum, we then subtract the mean squared. And the standard deviation is simply the square root of the variance. Or to put it a different way, the variance is the same thing as the standard deviation squared. In the special case of the binomial distribution, we don't need to go through the whole process of doing the summations because there's two very neat results. The mean for a binomial distribution with parameters n and p is simply np, and the variance for the binomial distribution with parameters n and p is np times 1 minus p. If we have a random variable which takes values x1 with probability p1, x2 with probability p2, etc., and that f is a function, then the expected value of the function of the random variable x is simply the sum of the function applied to each individual value of x times by the corresponding probability that the random variable takes that value of x. So we have the expected value of f of x is the sum of the fx values times the corresponding probabilities. In particular, that means that the expected value of the random variable squared is simply the sum of all of the x values squared times by the corresponding probabilities. Which means that the variance of x can be written as the expected value of x squared minus the expected value of x squared. You'll find that relationship comes in quite useful in some questions. Now let's have a look at some of the important properties of expectation and variance. In the first case, if a and b are constant numbers and x is a random variable, then we have the expected value of ax plus b is a times the expected value of x plus b, and the variance of ax plus b is a squared times the variance of x. If we have two random variables, x and y, then the expected value of x plus y is always just the same thing as the expected value of x plus the expected value of y. Moreover, if alpha and beta are two constant numbers, then the expected value of alpha x plus beta y is always going to be the same thing as alpha times the expected value of x plus beta times the expected value of y. Now if we look at the variance results, we need to know that x and y are independent. And if x and y are independent, that means the value of x doesn't affect the value of y. Then the variance of x plus y will be the same thing as the variance of x plus the variance of y. And moreover, if alpha and beta are constants, and x and y are independent random variables, then the variance of alpha x plus beta y is alpha squared times the variance of x plus beta squared times the variance of y. And finally, we have if x and y are independent random variables, then the expected value of x times by y is the same thing as the expected value of x times by the expected value of y. So at this stage we'll move on and have a look at some examples on expectation and variance. We have a bag that contains one 50p coin, two 10p coins and three 2p coins. We're going to take 3 coins out of the bag without replacement, and we've got to calculate the expected value and the variance of the coin of highest value in the sample that we have chosen. The first thing we have to do is work out the probability distribution for the highest value coin. Now the highest value coin, let's denote that by h, and clearly h can take values of 2, 10 or 50. We need to work out the corresponding probabilities. So, the probability that the highest value coin is 2p, worth 2p, is the probability that our first coin that we choose is 2p, the second coin we choose is 2p, and the third coin is also 2p. Probability the first coin is a 2p is 3 out of 6. The probability then that the second coin is a 2p is 2 out of 5. And then the probability that the third coin is also a 2p is going to be 1 out of 4. We need to multiply those together to obtain the probability that h equals 2 is 1/20th. We're now going to consider the probability that h equals 50, and to get the highest coin in the sample being a 50p coin, we need to make sure the 50p coin is in the sample, and the probability that the 50p coin is in the sample is 1 minus the probability that the 50p coin is not in the sample. So we can think of that as being 1 minus the probability that the first coin isn't 50p, then the second coin isn't 50p, and then the third coin also is not 50p. So that's 1 minus the probability the first coin isn't 50p is 5 out of 6, and then the probability that the second coin isn't 50p will be 4 out of 5, and the probability that the third coin isn't 50p will be 3 out of 4. So our probability that h equals 50 is 1 take away 5/6 times 4/5 times 3/4, which gives us a half. So we've got two of our three probabilities now, and the quickest way of finding out the third probability, the probability that h equals 10, is simply to remember that when we have a probability distribution, all of the probabilities have to add up to 1. So the probability that h equals 10 is going to be 1, take away the other two probabilities, which gives me 9/20. So we've now got the probability distribution for h. We want to work out the expected value of h. That's simply the sum of all of the h values times the corresponding probabilities. So that's 2 times a 20th, add 10 times 9/20, add 50 times a half, which gives us 29.6. pence as the expected value of the highest value coin. The variance of h is the sum of the values of h squared times the corresponding probabilities, take away the expected value of h squared. So that's 2 squared times a 20th plus 10 squared times 9/20 plus 50 squared times a half, take away 29.6 squared, which is 1295.2, take away 29.6 squared, or 419.04. The units of variance are the units of the data, that's in pence this case, squared. So the units, if we wanted to put it down, would be 419.04 pence squared. This calculation, once we have found the probability distribution for h, we could of course use our calculator to do the calculations for us. For our second example, we have two independent random variables, x and y. X has mean 5 and variance 2, y has mean 6 and variance 3. And for the first part of the question, we have to determine the values of the expected value of x squared and the expected value of y squared. Now this is where it's useful to recall the result that we know that the variance of x is the expected value of x squared minus the expected value of x itself squared. So for x, we know that the variance of x is 2, and that must equal the expected value of x squared take away 5 squared. That's the expected value, or the mean, of x squared, which tells us that the expected value of x squared must be 27. And we can do exactly the same thing to calculate the expected value of y squared. We know that the variance of y is the expected value of y squared take away the expected value of y itself squared. We know the variance of y is 3, and we also know that the mean of y, or the expected value of y, is 6. So we know that 3 is the expected value of y squared take away 6 squared. So we have the expected value of y squared must be 39. So we now know that the expected value of x squared is 27, the expected value of y squared is 39. We've now got to find the mean and variance of u, where u is x times by y. Well, the expected value of u is the expected value of x times y. X and y are independent, so the expected value of x times by y is the same thing as the expected value of x times by the expected value of y. So that's expected value of x is 5, the expected value of y is 6, so we've got 5 times 6, which is 30. We know that the variance of u is the expected value of u squared, take away the expected value of u squared. Now we already know that the expected value of u is 30. And we also know that u squared is the same thing as x squared times y squared. So the variance of u is the expected value of x squared times by y squared, take away 900. X and y are independent of each other, certainly means that x squared and y squared are going to be independent of each other. So the expected value of x squared times y squared is the same thing as the expected value of x squared times by the expected value of y squared. So that's 27 times by 39, and then we've got the subtraction of the 900 to deal with. So we've got the variance of u is 27 times by 39, take away 900, which gives me 153. For our final example, we have Saffron, who has 12 fair cubical dice, each of which has got faces marked 1, 2, 3, 4, 5 and 6. And she throws those 12 dice and counts the number of sixes that she obtains. And we've got to find the mean and variance of S. And then we've got Charlie's got 12 fair coins which he tosses, counts the number of heads he obtains, and we've got to find the mean and variance of the number of heads that he obtains. So first of all, for part A, we've got S is binomially distributed with n equals 12 and p equals 1/6. So the expected value of S is n times p, that's 12 times a sixth, which is 2, and the variance of S is np times 1 minus p, so that's going to be 12 times a sixth times 5/6, which gives us 5/3. For H, well, we know that H is binomial with n equals 12 and p equals 1/2. So the expected value of H is n times p, which is 12 times 1/2, which is 6. And the variance of H is np times 1 minus p, 12 times 1/2 times 1/2, which is 3. Saffron and Charlie agree the rules of the game. Saffron's going to be awarded 10 points for each 6 that she throws, and Charlie's going to be awarded 3 points for each head that he tosses. We're going to let t be the random variable that denotes the total score obtained by Saffron and Charlie. And we've got to find the mean and standard deviation of t. So t is going to be 10 times the number of sixes that Safi obtains, plus 3 times the number of heads that Charlie obtains. So t equals 10s plus 3h. So the expected value of t is the expected value of 10s plus 3h. And at this stage we need to remember our little list of properties of expectation and variance. And the expected value of 10s plus 3h is going to be simply 10 times the expected value of S plus 3 times the expected value of H. So that's 10 times 2 plus 3 times 6, which is 38. And the variance of t is going to be the variance of 10s plus 3h. And since s and h are independent of each other, the number of 6s that Safi obtains is going to have no effect at all on the number of heads that Charlie obtains, so they are independent of each other. So we can say that the variance of 10s plus 3h is going to be the same thing as 10 squared times the variance of s plus 3 squared times the variance of h. So that's 100 times 5 over 3 plus 9 times 3, which is 193.67. However, we're asked for the standard deviation of t, not the variance of t. We just need to remember that the standard deviation is the square root of the variance. So we've got the standard deviation for t is 13.92. To finish the question, we have to find the mean and standard deviation of d, where d is the amount by which Saffron's score, which is 10s, exceeds Charlie's score, which is 3h. So d is equal to 10s minus 3h. And there's nothing stopping us from saying that d is equal to 10s plus minus 3h. And if we do that, we can make use of the results that we've mentioned earlier on. So the expected value of d is going to be the expected value of 10s plus minus 3h. In other words, the expected value of d is going to be 10 lots of the expected value of s plus minus 3 lots of the expected value of h. So that is 10 times 2 plus minus 3 times by 6. In other words, 10 times 2, take away 3 times 6, which gives us 2. The variance of d is the variance of 10s plus minus 3h. Again, we know that s and h are independent, so we can say that that is going to be 10 squared times by the variance of h. So 10 squared times by the variance of s plus minus 3 squared times by the variance of h. So that's 100 times the variance of s plus 9 times the variance of h, which gives us 193.67 as the variance of d. So the standard deviation of d is the square root of the variance, which is 13.92.